Teach me about the Great Lakes. Teach me about the Great Lakes. Cha! Welcome back to Teach Me About the Great Lakes, a twice-monthly podcast in which I, a Great Lakes novice, get people who are smarter and harder working than I am to teach me all about the Great Lakes. My name is Stuart Carlton, and I work with Illinois Indiana Sea Grant, and I'm joined today by nobody because my co-host had to bail. I mean, we'll have a guest, but I don't have a co-host because Carolyn couldn't make it at the last minute. I blame her for that, but it's probably my fault, let's be honest. But I am excited today because I've been really getting into lately with this pandemic in particular. I've been getting a lot more into birds. I was an ichthyologist by training before I became a social scientist, but I've got these kids and we love running around looking at birds. My one-year-old daughter the other day heard a crow cawing and said, "Hi, crows," and my heart melted. So now I like birds. And so today our guest works for the National Audubon Society. Her name is Joanna Graham, but let's just go ahead. We'll do some interstitial music and then we'll bring her in. Our guest today is Dr. Joanna Graham, a senior spatial ecologist with the National Audubon Society. Joanna, how are you today?
I'm doing great. How are you doing?
I'm doing great. Thank you. I'm really, like I said in the intro, happy to have you on, but I want to understand what it is you do. So what is a spatial ecologist exactly?
Yeah, that's a great question and one that I get asked often. And it's not so easy to explain, but I will try. So basically, the study of spatial ecology is the study of how organisms and landscapes are distributed across the surface of the planet. So as a spatial ecologist, I study that spatial arrangement of populations and landscapes and how they influence ecological dynamics, and how, for example, more importantly, how humans change and modify the distributions of those populations and landscapes, and how that impacts species and leads to declines.
So sort of the main thing, I guess, that makes it spatial is you're looking over what you're calling landscapes. Like what is a landscape? Is that just like a one field, or is it much broader than that? How do you even define a landscape in the sense that you're using it?
Yeah, a landscape can be any size, really. There's no limit. I mean, it can, and it sort of depends who's asking the question. So a landscape to an ant could be very small, could be your coffee cup, versus the entire planet could be a landscape, depending on your perspective and what you're interested in studying. Yeah.
I see. So really the space can really vary. And do the types of questions, I guess, so it seems like the types of questions you would ask about a coffee cup size landscape are they different from the ones you ask across a region or a continent or something?
Yeah, for sure. As a spatial ecologist, mainly the data that we use to answer questions about modifications to the environment comes from remotely sensed information. So we mostly look at very broad spatial scales, and we get our information at that scale from satellites, okay, airplanes, drones, things that are looking at the planet from far away.
Yeah. So one secret sort of theme to this podcast, it turns out, is the importance of all these data sources. Because whenever we talk to, or not whenever, but a lot of times when we talk to scientists, they're talking about all these data that they rely on. So Audubon Society doesn't put out satellites, right? Are these, things that are available from government or private corporations, or?
Yeah, exactly. We don't have our own satellites. Yeah. But right, exactly. So there are hundreds, maybe thousands of satellites at any given time orbiting the Earth, and so we use the free data comes usually from the federal government, and so mostly we use that. Yeah. Although there are private corporations that also collect these data, and often those data are available at higher resolution than the publicly available data. But you have to pay for it.
Yeah. So higher resolution means it's like a more fine-grained what's available.
Exactly. Yeah. So like the Landsat satellite, their imagery comes in at about 30-meter resolution, whereas there are other more the corporate satellites might be much more high resolution than that.
That's because the government saves the good stuff for the military, I suspect.
That's right.
Or the NSA,
Right.
to whom I'm waving right now as they watch us record this.
Exactly.
Yeah. Okay, and so you work for Audubon Society, so that means you must have an interest in birds. How did that come across sort of second, or was it first? Hey, I like birds, here's how I can study them. Or I like ecology, and birds are a cool species to study. Or a cool clade, whatever the right term is.
Yeah, that's a great question. Actually, for me, it wasn't just birds. I mean, I've always been interested in wildlife and the environment in general. And so, actually, my dream when I was a kid was to be Jane Goodall.
Oh, sure.
I was interested in primates, but life takes different turns, and I ended up in the environmental field, and that led me to the Audubon Society, and now I study birds.
Very cool. And so, like I said in the intro, I'm learning more and more about birds. I know squat about them, but that's okay. But one reason that birds are important, in addition to being interesting and beautiful and all of that, is that they use a lot of valuable habitat, right? And when you're studying birds, I think you're also studying things like wetlands and marshes and what have you. So why are and so some of your work has been trying to prioritize that, right? Looking at different marshes or wetlands and trying to prioritize those for conservation in the case of limited resources. But why are coastal wetlands important for birds? What do they use them for?
Yeah, so marsh birds are essentially use coastal wetlands or any wetlands for different stages of their life history. Some of them are what we call obligate marsh species, so they spend just about all their entire life cycle in marshes. So foraging, breeding, resting, basically every aspect of life is in the marsh. Then there are some species that only use marshes for part of their life cycle. So maybe they'll just breed in the marsh or forage in the marsh, but then they spend other parts of their life elsewhere.
Uh-huh. And
in any case, for most birds, it's a critical, for marsh birds in general, it's a critical piece of their life cycle.
Right. And so in a sense you're using it. So for example, red-winged blackbirds, which are these really obnoxious birds that I love because their coloration is just so striking. And because the males are just ridiculous. They will stand on like a tree and go, bah, 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 and just like be obnoxious. It's like, oh, chill out, man. But I like that. If you're going to come strong. But so they'll like fly around in the sort of the local marsh, the celery bug, we call it here. But they'll also be in cornfields or whatever. So would those be marsh birds by your definition, or is that something else?
Those are wetland birds.
Okay.
Yeah, they mostly use wetlands, exactly. And they're pretty ubiquitous. They're kind of everywhere.
Yeah.
But yeah, so those are wetland birds, I would call them.
Okay.
Yep.
And then some of the obligate, I assume that's just from that word like obligated or obliged. So they have to stay there or else they die a horrible death, I guess. So what are some examples of those, just so I can put some links in the show notes for our listeners?
Oh, let's see. So there are these this type of marsh bird called secretive marsh birds.
Ooh.
Yeah, they're hard to find. For you can tell from the name that they hide in the marshes and they don't vocalize very often. And so a lot of these are obligates. They're like the bitterns and the grebes and rails, animals like that.
Right. Well, I'm putting these on my to find life list. I will find a secretive marsh bird and report back. That's great.
Cool.
And so, yeah, I'm from the Southeast. I was born and raised and moved here a couple of years ago. And so when I think of like wetlands and stuff, I think of like the coastal swamps we had in New Orleans or in Louisiana where I grew up. And then, throughout like Florida and Alabama, Mississippi and all that. But so around the Great Lakes, so I assume there's just a ton of wetlands here. I mean, we got the lakes, right? But are there different types when you're thinking about these? Do you classify the wetlands too? What are the different ways that you look at those?
Yeah, so there are different types of wetlands, and specifically in the Great Lakes, there's 3 different types. There's barrier wetlands, which are more protected, and they're found in where there's barrier islands protecting them from the open water. Then you've got lacustrine wetlands, which are more open to to the lake itself, although not completely. They're more in bays. And then there's also riverine wetlands, which are mostly found at the mouths of rivers where they open up into the lakes.
And if viewers, I almost always call them readers, and I about did it again. If readers or viewers are interested in learning more, go ahead and look down at your podcast player right now, and we'll have some links in the show notes to some resources about those. That's great. And so we have this variation in different types. And so part of what you work on is trying to prioritize these for conservation. And so if they need to be conserved, that means there's threats, right? Now, I'm going to guess that the threats are things we hear about a lot, like climate change, runoff, eutrophication, those sorts of things. Are those like the big picture threats? Are there other ones that I'm not thinking of?
Yeah, that's pretty much it. I mean, sea level rise is huge. Human development obviously has been one of the biggest problems over the past 100 years. Of course, there's pollution, invasive species, fragmentation, drainage of wetlands, all kinds of things. But yeah, mostly the usual suspects.
Yeah, I hear that. And so when you're trying to think about this, trying to prioritize wetlands across the Great Lakes for conservation, I mean, you're talking about trade-offs. And essentially, or what are the things that go into trying to even approach that problem? It seems impossible to me, frankly, because, I mean, if you think about the Great Lakes, they go from Minnesota over to New York, essentially, plus we have Canada. And so I don't even know how you would begin to investigate that problem. So what are kind of the thoughts that go into that?
Yeah, so, of course, everybody comes at prioritization from their own perspective. And since I work at the National Audubon Society, our perspective is mainly around the birds. And so we use birds in general as indicators of healthy systems. So for us, marsh birds really tell us where the important wetlands are just by how they're distributed already in the environment. And a lot of them are still in places that are highly modified, very urbanized areas. But at some point, we need to be careful that we don't cross a line at which those species then move out of those areas. So a lot of our priority sites that we found were in highly urbanized areas, and those I think are pretty important to pay attention to.
Mm-hmm. And so I take it you did some modeling here, right?
Yep.
Probably some, I'm going to guess, some spatial ecological modeling, I suppose. And so you put variables into there, I guess, right? And so some of that's going to be from this satellite data. What kind of variables, to the extent that you can explain it to people like me, what type of variables go into your models?
Yeah. So like I said, we study these things from the 30,000 foot view. So our environmental data that went into the models were things like we look at sort of an area around every point where we collect bird data, and we can tell from satellite imagery what kinds of land uses are happening in that area. So we look at things like proportion of agriculture within the area that's being surveyed, or proportion of impervious surfaces, proportion of open water, or proportion of different habitat, wetland vegetation types like herbaceous vegetation or woody vegetation. We also looked at lake levels over time. That's pretty much it, I think.
Okay.
Oh, and also invasive species. We had some information on the distribution of Phragmites across the coastal wetlands.
Phragmites. Let's pretend, for the sake of our listeners, and not because it's true at all, that I don't know what Phragmites is.
Yeah, so it's a common reed. It's an invasive species, and it's everywhere, and it's a very big problem for wetlands because it really basically pushes out native species and creates these like walls of reeds.
Mm-hmm. I see. And so you're looking at kind of the habitat characteristics of these areas. Is this agriculture land? Is it impervious? So is it concrete or,
Exactly.
buildings or whatever? Yeah. Parking lots, and vegetation and stuff. And so you sort of assign a score, essentially. Is that a fair way to put it, to these different variables?
Yeah.
And then...
Yeah, eventually there's a bunch of different phases in the modeling, and eventually we do get to the point where we figure out where every species could potentially inhabit, what would be a suitable habitat for every bird that we're modeling, and then we use that information to assign a score to that particular site,
Right.
depending on how many species are using it and what abundances.
And then when it comes time to like investing resources, it's just a question of then looking at, you know, the score and various other factors, I guess. You know, maybe there's political factors, which it sounds like maybe you didn't account for.
Yeah. We don't get too into the political piece of it. At least I don't in my work. We have a whole department that handles that piece. But but yeah, we look at things like whether it's already protected or not. That's a big piece.
Yeah.
But then, of course, you know, that doesn't answer the whole question, because even if it's protected on paper, it doesn't really mean it's actually being protected.
There's protected, and then there's protected.
Exactly.
Yeah, that makes sense.
Yeah.
And so one thing, when I think about models and modeling, one question that I think comes up a lot that's fair is like uncertainty. So you're doing all this stuff from afar. I think are you in New York? Is that right? Or DC?
I'm actually in Massachusetts.
You know, if you give me 4 or 5 guesses, I'll remember. It was just yesterday when I looked it up. In Massachusetts. You're there in Massachusetts. It's a Great Lakes state. No, it's not. It's connected to a Great Lakes state. I'm going to delete that so I don't look like a moron. So that the full extent of my moronity is not revealed. But so you're in Massachusetts and you're getting all these data. So like there's got to be uncertainty, right? How can you know that? Or you can't know, but like how do you deal with that uncertainty, I suppose, when you're doing this kind of work?
Yeah, that's a huge issue. And we have lots of ways of sort of quantifying uncertainty, and there are lots and lots of sources of uncertainty. There's uncertainty in every single data set that we include in our models, right? From down to like, did we actually count the number of birds that were there? Did we see them all? Did we, what's the resolution of the satellite data, and how is the information classified? There's tons of uncertainty. And so because this is so pervasive in my work, I like to always think about a quote from a statistician named George Box. And what he said, George Box, yes. He said, I think it was back in the 70s, he said that all models are wrong, but some are useful. So I like to think about that whenever I produce a model and wonder about the uncertainty. And you know, another thing he said, I'll quote this because I think it's just so perfect. Since all models are wrong, the scientists must be alert to what is importantly wrong. It is inappropriate to be concerned about mice when there are tigers abroad. So in my mind, this means, you know, we're in the middle of the 6th extinction crisis, right? 3 billion birds have been lost since the 1970s. Everything's a mess. We need to take action now with the best information that we have available. So, you know, we spend a lot of time trying to get these models as right as they can possibly be, but we know they're never really truly accurate. But it's the best information we have right now, and we need to act on it. And what's the worst that can happen? So we protect maybe an area that doesn't have the most species. It's okay. We protected it. We protected something.
Mm-hmm.
So I don't worry too much about how wrong the models are, as long as, you know, we get the basics right.
That reminds me of another quote that I use all the time, which has been attributed to everybody, but I'll say John Maynard Keynes, and that is, it's better to be roughly right than precisely wrong.
There you go. Yeah. That's a great one.
And so you would say then that your modeling, of course, there's errors and uncertainty, but it is useful. It is roughly right in that it gives kind of a framework for thinking about these problems. Or am I putting the wrong words into your mouth? I apologize if so.
No. I think that's perfect. I think it's great. And a lot of the way I think about these types of models are that they're kind of initial screenings. You know, like we can't go out and survey every wetland in the Great Lakes and figure out what really needs protecting and what really needs restoration. I mean, it's just, there's no time to do that kind of work. So we use this remote data to get sort of a first sort of screening of the whole landscape and what that looks like. And then we can go in a more targeted way in the field and actually try to validate some of this stuff.
What blows my mind thinking about it is that this is even doable, though. Like your field can't be that old in terms of, or at least the types of stuff you work on, right? Because this satellite stuff has to have been available for it to work.
It's true. We do, you know, at this point have satellite data back to the 70s. Mm-hmm. So, you know, the information's been around for a while, and it just continues to exponentially get better, and there's more of it, and it's more available. So the field is really just, kind of exploding.
Yeah. So how is and this is a tangent, so I apologize for that. Other than I think it's interesting. So how does that change? I mean, as technology just keeps getting crazier and crazier, right? In terms of what they can do. Now there's the Internet of Things, which as far as I know is not actually a thing, but maybe it is. It sure is a buzzword you can put in your proposals. And, so like, what does this look like in 10 years, do you think, in terms of what is technology going to enable you to, what questions are you going to be able to answer, do you think, in like 10, 15 years that you maybe can't approach now as technology moves?
Yeah, that's a great question. I think that over the next in the future, I think that things are going to move more toward automation of monitoring. Like now, we spend a lot of time and resources paying people to go out into the field and collect data on biodiversity and endangered species. And in the future, there are going to be things, and they're starting already to be available, like acoustic monitoring techniques, where you could just put a recorder out into the middle of nowhere and have it collect all the data on animals and their sounds, and create these soundscapes that then we can then take back to the lab and analyze without ever having to send somebody out into the field except to put the recorder out.
Hmm.
So things like that, I think, are going to really revolutionize.
Yeah, that reminds me of some of the work that Brian Pijanowski here at Purdue is doing. What does he call his thing? Oh boy, Soundscapes. Yeah, his Soundscapes project that he does is all into that. That's really
really cool stuff.
Yeah, it's fascinating to see where that goes. On my field is social science. Like, I feel like there are smarter people than me who are going to figure this out in terms of how to use technology to collect data. They'll be really useful as survey response rates keep going down. It's an exciting time, a terrifying time, but an exciting time too. Okay, good. Well, so thinking about birds and wetlands degradations and stuff like that. So, if people are really worried about that, what are some things they can do? I know the challenge is these big problems. Like, I can't do squat about deforestation or climate change as an individual. It's really hard to do. But are there steps that people can take in your opinion?
Absolutely. I mean, it's sort of cliche, but like every little thing that every person does kind of adds up to something bigger, right? And I think one of the important things to think about, especially if you're concerned with coastal wetlands, is if you're lucky enough to be, or maybe unlucky enough to be, one of those people who has coastal property at this point. I think it's really important to think about things like living shorelines. If you're trying to mitigate, impacts of sea level rise, not to just go ahead and put up a concrete bulkhead, but use living shoreline techniques that stabilize the earth with natural materials, and also provide habitat for animals. So they provide these important co-benefits for both animals and people. So that's one thing that people can think about. Obviously the usual ways to protect the environment, like not using toxic chemicals and flushing them into the groundwater, or things like that. There's also ways to if you want to really do something more on the ground, you could volunteer for Audubon Great Lakes and go out and help clean up the wetlands. They have these stewardship volunteers there that are always welcome. Obviously, not happening during a pandemic, but hopefully one day this will be over and we can get back to work there.
If not, we won't have to worry about it, so that's fine.
Wait,
this went dark. I apologize. Let me pull it back.
I usually do that. I'm glad you did.
No, those do sound like some concrete steps. And boy, you're speaking my language with some of that. I will put a link in the show notes to the webinar that I led on living shorelines back when I was at Texas Sea Grant.
Great.
That's wonderful. Okay, one more question that was not on the initial list, but now I'm curious. So in my work life, my job is to really look at the subtleties of sort of the human experience and people's attitudes and opinions. And so in the rest of my life, I like to not look at those subtleties. So I'm just going to want you to name something here. No subtlety. What is the best bird?
Best bird.
Yep. You got to crush the hearts of almost every bird out there. And then I'll tell you the actual answer. Yeah.
This is a terrible question, but I guess I'm going to say the wood thrush.
Wood thrush. Tell me why it's the best bird.
I love the wood thrush because I love its song. It sounds like a flute.
Really?
Yes, and if you can go online and find recordings of it, it's just the most beautiful sound, and I hear it all the time around my house, and it's just that familiar sound that I just love to hear.
All right. Wood thrush. I will put that in the show notes. We'll put links to it, and I will listen to some wood thrush. We're recording this on a Friday behind the scenes, so this afternoon I will be listening to wood thrush songs. Yeah. Well, Joanna, this has all been really interesting, but that's actually not why we invited you on Teach Me About the Great Lakes this week. We invited you to Teach Me About the Great Lakes, ask these 2 questions. And the first one is this. If you could choose to either have a great donut for breakfast or a great sandwich for lunch, which one would you choose?
This is a timely question, actually.
We aim to serve here.
So I'll answer the question and I'll tell you why it's timely. It's for me, I would go with the great sandwich for lunch. And it's timely because my son and I have been really researching very hard whether we can find a panini maker that's non-toxic.
Oh.
Because we love paninis. And apparently such a thing does not exist. They all have Teflon. And I won't buy things with Teflon. So I struggle to make a great panini.
Yeah, that is a big challenge. We've had the same issue with like waffle makers.
Yes.
And I found one that was made out of cast aluminum by some company, but I still think it had a secret coating on it. I don't know.
Yeah. There's always something.
It's always a secret.
Iron. I think cast iron's your best bet.
Yeah. I've got a cast iron griddle, but no cast iron. I could just put the cast iron pan on top of the cast iron griddle. It will crush my stove, but you get a nice panini. So that's good.
Absolutely. That could work.
Sounds good. And then, I forgot the critical follow-ups. You're in Massachusetts. Are you in the Boston area or?
No, I'm in the Western Massachusetts.
Okay, so there are other areas in Massachusetts. Okay, so when I'm visiting your area, where can I go to get, other than a panini at your house, where can I go to get a really great sandwich?
Well, that's the problem. We don't have a great sandwich place here.
No.
I've been complaining about this. I've been living in this area for about 10 years, and I've been complaining, and nobody's listening.
You're in a sandwich desert. It's just, you hate to hear it.
Yeah, I think so.
I hate to hear it. Yeah, same here in West Lafayette for pizza. There's not a single good piece of pizza in this whole town. But the people who grew up here don't believe me, and I'm like, trust me, there's no good pizza. No, I've tried it. It's no good. Yeah.
With, right?
I know the place you're talking about. It's not good pizza. Hello, Ethan, if you're listening. All right, great. And our second question is, what is one piece of life advice that you have for our listeners? It can be big or little, serious or silly. We've had people, quote RuPaul. People give the advice they give to their graduate students or their children. Sometimes it's the same. So whatever you think. We just like to leave the listeners with something to reflect on as they close out the podcast.
Yeah, I guess I would say that my advice is to learn one new thing every day.
I like it. I'm writing it down as we speak. And today I've learned about the beautiful wood thrush song that I will spend the next few minutes reveling in after this.
That's perfect. You're done for the day.
Done for the day. Good. Go find a panini and take a nap. Excellent. Well, Joanna Grand, where can people go if they want to find out more about the work that you're doing?
Oh, yeah. I think go to our website for sure, the National Audubon Society website. We have a page specifically dedicated for the science work that happens at Audubon. So a lot of it is covered there. That's the best way to get the information. Yep.
Well, perfect. We will enjoy doing that then. Joanna Grand, a senior spatial ecologist for the National Audubon Society. Thank you so much for coming on and teaching us about the Great Lakes.
Thank you. It was good to be here.
That was really great. Thank you to Joanna for coming on, and thank you to you for listening. I encourage you to follow us on social media feeds. You can find Illinois Indiana Sea Grant all over social media at ILIN Sea Grant. You can follow the show on Twitter at Teach Great Lakes. And of course, I encourage you to check out the Sea Grant webpage at iiseagrant.org. And that's all we got for this week. We'll see you the first Monday of every month and the third Mondays of most months. Thanks, stay safe, and keep grading those lakes. And I was like, well, shoot, let's kill two birds with one. Oh, sorry.
Oh, no, you can't.
No. Let's catch two marshes with one satellite. And
there you go.